Here is another truss problem. So we have a set of forces acting on this cantilever here. It is supported with a pin at A and a roller at G, so it can't move. And we're asked to draw the free body diagram of a section of the truss that will allow you to find the forces in the members CD, DI, and IJ. So let's see, where do we have CD, DI, and IJ, right? So we will, if you use method of sections, we'll need to cut somewhere along that line, right? So we can expose those forces there. Now that means we'll have to draw the free body diagram either of the left side or the right side. Now in previous problems we first found our support reactions, but in this case we don't really need the support reactions, right? If we take the right hand side of this cut, right, so D, E, F, L, K, J, then we don't need the support reactions because they're not going to show up. So we will draw our free body diagram of the right side, not the left side. Of course, we could use the left side as well, and we'd get the same answer, but we would need more computations because we would first have to get the support reactions. All right, so let's do our two boxes here, and we don't really need the internal parts of the boxes, so we're just going to draw the outline. And then what do we have? We have a couple of forces acting it. So we'll have J, K, and L. We'll draw the locations in though. J, K, and L. So let's say this was J, K, L. And those are all 50 kilonewtons. So 50 kilonewton, 50 kilonewton, 50 kilonewton. That's there. So we have no other loads on it. So that means the only thing that's left over is going to be the three support reactions, right? The three member forces that we're cutting, right? So we'll have something here, something there, and something there to represent kind of where we cut those members. All right, so we'll have up here at, let's put the names on here too. That would be D. No, E is not really all that useful to us. F, yeah, I don't think we'll need F either, so I'll just put D on there. So we will have CD, right, because it was connecting over to there. It's one of the forces that we want. Then we will have DI going downward, FDI, and then in this direction there'll be FIJ. FIJ. Three unknowns, three equations. Should be easy to do. All the distances are 2 meters, so it's 45-degree angles for anything that we have. All straightforward. Now, just the same as we did for the other problem, we're going to draw in our little point here, which was point I, because again, we can do the moment around point I, and then everything but FCD is going to drop out. All right, so that was our free body diagram. Let's do a coordinate system, X, Y, and I think that's all we needed for A. So now it's just go ahead and figure out what those support reactions or what those member forces are. In B, so what do we do? Well, I think we'll use a very similar approach to what we did before, and that is we will do a sum of forces in the Y direction equal to 0, right? Because FDI is going to be the only one that has a component in the Y direction. So what do we have? We have minus 3 times 50, so let's just do minus 150 kilonewton. And then we have minus FDI, because it's going downward. And it's a 45-degree angle, so 1 over square root of 2 FDI, right? 45-degree angle because the width and the height both are 2 meters, so that means we have a 45-degree angle, and sine or cosine of 45 is 1 over square root of 2. All right, that's a pretty easy equation to solve for. So solving for f di will be negative, right? Because both of those are negative, which means 150 times square root of 2. It's really not much there. Times square root of 2 kilonewton. And if we put that in the calculator, 212.13 kilonewton negative, so we get compression. That's FDI. And now for the other two, I would suggest we do moments. The first moment around D. So sum of moments about D equals 0 equal to D. That means of my member forces only Fij is around. Fij is turning clockwise, so minus Fij, and that was all 2 meters or 3 meters? 2 meters times 2 meters. Then the 50 kilonewton here at J, the line of action goes through D, so that's 0. Then the next one for K will have a distance of 2 meters, and it is turning clockwise as well. So minus 50 kilonewton times 2 meters. And then the one at L, also turning clockwise, so another 50 kilonewton. And now it's going to be 4 meters, 2 plus 2. All right, single unknown. Solve for F Ij is equal to, so it's a negative sign, so all these negative signs stay together. That means we get 50 kilonewton times 2 would be 100 kilonewton meters. And then because we have a negative sign in front, we'll do plus. And that's times 4 is 200 kilonewton meters divided by 2 meters. So that'd be minus 300, so minus 150 kilonewtons. And if it's negative, it's in compression. I didn't even need a calculator for this one. All right, so we did the moment around D. So now we're going to use our trick again and do the moment around I, right? Because FDI and Fij, both the lines of action are going to go through I. So we do moment around I. Sum of moments around I equals 0. Equal to, what do we get at I? We get FCD turning counterclockwise at 2 meters. So FCD times 2 meters. Then we get all three of those. All the three forces, they're all going to be turning clockwise. And so we're going to step up by 2 meters each. So we have minus 50 kilonewton times 2 meters minus 50 kilonewton times 4 meters minus 50 kilonewton times 6 meters. All right, we'll just go step by step. 2, 4, and 6. All right, so what does that give us? FCD is the only unknown. FCD was positive, so we have to move all those over. So 50 times 2 is 100 kilonewton times meter. 50 times 4 is 200 kilonewton meter, and then plus 300. Divided by 2 meters. That makes it nice and easy. So we get 200 plus 100 is 300. 600 divided by 2 is 300. 300 kilonewton. So it is in tension because we got a positive one. All right, with that, we have all three of our Member forces, didn't even really need a calculator other than I guess to get the decimal here. And once again, we didn't use sum of forces in the x direction, so maybe we'll do that real quick to see as a check. So if we do sum of forces in the x direction, sum of forces in x equal to 0 is equal to FCB Fij, both negative, FCD minus Fij minus FDI, but 1 over square root of 2. 1 over square root of 2 FDI. What does that give us here? That gives us, let's see, minus FCD, minus 300 kilonewton. Then minus Fij, it's minus 150, so minus plus minus. And then minus 1 over square root of 2 times FDI was minus 150 times square root of 2. Minus 150 square root of 2 kilonewton. And that's then minus 300 kilonewton. Minus plus minus as plus. 150 kilonewton. The square roots cancel out. And we have minus and minus as plus, so plus 150 kilonewton equal to 0. Excellent. So we got a little test in here, and we think it's correct. All right. So we were able to get the member forces CD, DI, and IJ, all without having to find the overall support reaction. So it was pretty fast.